Welcome to Engage New York, Module 4, Lesson 32. This is Concept Development. So let's take a look at this first problem. What do you notice about this expression that would help us translate the words into mathematical symbols? Let's read it. Twice the sum of 3/5 and 1.5. So, what do you think? What do you notice? What do these words mean? And how do we take the words and translate them into a mathematical equation? Because this is a mathematical expression, but now we need to put it in a mathematical expression with numbers and symbols. So what does it mean? Well, it says twice. That means we have to make 2 copies of something or multiply by 2. It says the sum of. So something is being added. The part says sums of needs to be added before multiplying. So the part that says sum of needs to be added before multiplying. So we'll need what? What do you have to do to signify that you are going to do something first? What in math tells you, hey, you have to do this part of the expression or the equation first? That's right, it's parentheses. So let's take a look at the first part of the expression. Now, how do we write twice numerically? That means with number symbols. How do we write it numerically? So we say 2 times, right? All right, excellent. What is being multiplied by 2, though? What is being multiplied by 2? Twice what? The sum of 3/5 and 1.5. So it's the sum of 3/5 and 1.5. So how do I write the sum of 3/5 and 1.5 numerically? Well, we say 3/5 plus 1.5, right? Okay, is there anything else we need? What did we discuss earlier? Yeah, you need parentheses. Why do you need parentheses? Well, you have to have parentheses around the addition expression. This is so that the addition is done before the multiplication. Because what do we know about PEMDAS? Parentheses, exponents, multiplication, division, addition, subtraction. So parentheses tells us we have to do this first, right? If you don't, the answer is going to be wrong. Otherwise, you just go, if we didn't have the parentheses, remember, we just moved from left to right, and then we'd multiply first, right? Okay. So now this could be written 2 different ways. This could be written, depends on how you like to write it, but I generally will try to write the numerical expression or equation in the order that you see, that you read the problem. Okay, you want to read it. So this is an expression written in words. So I like to write my expression, my numerical expression, in the same order that I see, that I read the words across. But if you wanted to do 3/5 plus 1.5 times 2, that is perfectly perfect as well. That is mathematically sound. It's just sometimes I think if you do this, maybe you forget something. But if you follow the equation, you're less likely to get lost or lose something that you need to do. All right, now let's read this one. Half the sum of 3/5 and 1.5. So let's compare the expression to the one above. Now, without evaluating, which means solving, right? Without evaluating the expression, will the value of this expression be more or less than the previous one? Think about it. Will this one be more or less than this problem here? Did you say less? It's less. The other one is multiplied. The other one multiplied the sum by 2. And this one is taking half of the same sum, right? And then, so half of a number is less than doubling it, right? So let's write this out. So half the sum of 3/5 and 1.5. And yes, you could write it 3/5 plus 1.5 times 1/2. And technically, you don't have to have that multiplication sign there. You could just have a half right here. And the half next to the parentheses automatically says, hey, you're multiplying. So we multiply it by a half. We can show a half times the addition expression, or we can show half the addition expression times half. So here or here, right? So taking a half of something is the same as dividing it by 2. Yes, so taking half is the same as dividing it by 2. So we could divide the addition expression by 2. We could divide the addition expression by 2, but write it like a fraction with 2 as the denominator. Okay, so technically, we could write it like this as well. 3/5 plus 1.5 over 2. Because really, it's this times 1 over 2, right? So just a little, this is taking it to the next level right here. So what does this equal? Can you solve it? 1.5 times 3/5 plus 1.5. I bet you could. Let's try it. I want you to solve number 1 and number 2 and come back and check your work. We've written it out because that is our big idea for today, but getting the right answer because you wrote it correctly is the big idea. Solve it and come right back. All right, I did go through and solve it. I got 4.2 for number 1 and I got 1.05 for the second. So it is less, isn't it? All right, now let's go to problem 3. The difference between 3/4 and half divided by 3. Read that again. The difference between 3/4 and a half divided by 3. All right, so what do we know about this expression? What is happening in this expression? Well, the difference means subtract, right? So 1/2 is being subtracted from 3/4. So the difference between 3/4 and 1/2. So half is being subtracted from 3/4, And then the last part says divided by 3. So we can put parentheses around this subtraction expression and then write divide 3. It says divided by 3, right? We can write that like a fraction with 3 as the denominator, or dividing by 3 is the same as taking a third of something. So we can multiply the subtraction by a third. So how do you want to write it? There's 2 different ways to write it. So you could say the difference between 3/4 and a half divided by 3. You've written it, it follows the words, it's perfect. Now, you could also write it like 3/4 subtract 1/2 over 3. And that's essentially the same thing as 1/3 times 3/4 subtract 1/2. So, which way do you want to solve it? So all of these are the same thing, but you can just write this different ways. Maybe your brain sees it a different way. But for me personally, following the words makes it the easiest. So dividing by 3 is the same as taking a third of something, so we can multiply the subtraction expression by a third. So there's 3 different ways to write this problem, and you are perfectly mathematically sound. Now, can you actually solve it? Go ahead and solve and come back and check. Okay, so how did you do it? I just used the first expression, but either of these would work. All right, moving on to problem 4. Let's put this expression into its simplest form. So what is the first step? Now we're going to take the mathematical expression and we're now going to turn it into words. So what's going on here? Now listen, if there are parentheses in the expression, you want to address what is in the expression first, because you have to actually do that first. I'm telling you, it'll make your life so much easier if you just address what's in the expression, what's in the parentheses first. So, because we need to evaluate the numerator before dividing it by 3, oh, sorry, just kidding. So, I'm telling you, we want to use the simplest method to try to writing this out. So, how can I turn this into words? So I have to address the parentheses first, right? So we're going to rewrite a numerical expression in word form. What is happening in this expression? Well, in the parentheses, there's a difference between 1/2 and 4/10, and then it's being multiplied by 2/5, right? So how could we write this in word form and make sure that we're showing the operations correctly? So a word form expression for the operation outside the parentheses would be what? Times 2/5, right? Okay. So how should we write this out? So should we write the difference between 1/2 and 0.4, and then what? divided, you could say divided, you could say multiplied. What do you think? I'm going to say, do you know what? I'm going to go back and say multiplied by, or times. I like times better. Times what? 2/5. So let's go back over this. The difference between 1/2 and 0.4, so the difference between 1/2 and 0.4, we're starting with it because it has the parentheses, times 2/5. What do you think? I think that looks good. So, what do you think? Is there any other way that you might like to write that? I want you to think about it for a moment and see if there's something you can come up with. I did not come up with anything that I would do differently. Maybe you could say 2/5 times the difference between 1/2 and 0.4. That would be fine because you would be following the expression. You could say 2/5 times the difference between 1/2 and 0.4 would be another way to write it. Absolutely no problem. You would just have to remember that you have to do the parentheses first. So 2/5 times the difference between 1/2 and 0.4 would totally work too. All right, now let's look at this problem here. So 3/4 plus 1.25 and 1/3. How can we take our numerical expression and put it into words? Is there something that's jumping out to you that says, hey, I have to do this first? Well, it should. 3/4, the sum of, so let's go, the sum of 3/4 and 1.25. And then what? What do you want to say? What should we say? Divided by 1/3. So the sum of 3/4 and 1.25 divided by 1/3. You could say 1/3 divide the sum of 3/4 and 1.25, but I really try to stay with following the equation. What do I do first? That's where I try to keep my translation. Okay, last problem. 2 divide 1/5 times 0.3. So, what do you think we should do? We could say, what do you want to say? We could say the quotient right? The quotient of 2 and 1/5 times 0.3. So the quotient means the answer. So the answer from here is multiplied by 0.3. So the quotient of 2 and 1/5 times 0.3. So remember, you have to find 2 divide 1/5 first before you can multiply by 0.3. And when you solve this, you get the quotient. The quotient is the answer. So the answer of 2 divide 1/5 times 0.3. You could do that. Anything else come to mind? So 0.3 times, you could go 0.3 times the quotient of 2 and 1/5. But again, I really like to follow the order. It really does make a big difference. And you're just less likely to mess up the problem. If you just follow the order, what do you have to do first? Start with what you have to do first. All right, that's going to do it for concept development. So now you're ready for the problem set. So let's just take a look at the problem set together before you get started. Circle the expression equivalent to the sum of 3 and, so the sum of 3 and 2 divided by 1/3. Now remember, we were just writing problems. You can write them in different ways, right? So going back here, the difference between 3/4 and 1/2 divided by 3, there were 3 different ways that this problem worked perfectly fine. That's what they're getting at, is how could you write this problem 3 different ways and still get the same answer? So if you want, you could just solve this right here and solve each one of these. That would make absolutely sure that you are on target. But you're really trying to look for the idea, the sum of 3 and 2 divided by 1/3. What does that look like? It looks a few different ways. Now, that doesn't look right to me. A couple of them do look right for me. Remember, they don't necessarily have to follow the same order. Remember, I was showing you, you could flip the problem around, so keep that in mind. Circle the expressions equivalent to 28 divided by the difference between 4/5 and 7/10. Same idea here. Then in problem 3, you are filling in the chart by writing the equivalent numerical expression. So you're translating the words into the expression for each one of those. Then it says compare 3a and 3b. Compare the two. Now, without solving them, identify the expression that is greater. How do you know something's greater? Now, we talked about it back over here when we said twice the sum versus half the sum. Remember? Something that's twice as much is 2 times as much. Something that's half of as much is half. So think about that as you answer A and B. So you actually need to use words. The difference between problem A and problem B is, okay, you're writing this with words here. All right. Here you're filling in the chart. Now you're starting with the words. Starting with the words, you want the words to match the expression. The words need to match the expression. Now, I highly recommend start with what you have to begin the problem with. Just makes it easier. Then it says again, compare A, and C this time without solving it. I'm not even asking you to solve it. Identify the expression that is less. Now, how do you know it's less? That is remember, going right back here. Twice the sum, half the sum. Looking for words like that to help you know automatically which one is greater or less than. Then this one you have to actually evaluate. Evaluate means solve, right? You have to actually solve these. So break it down and actually give me an answer there. That's the same for D, E, and F. You're actually going to solve those and write the answer. So yeah, you're going to have to write out a math problem here and solve it. Choose an expression below that matches the story problem and write it in the blank. So out of these expressions, which one belongs to this problem? Out of these 4 problems, which one goes with this word problem? So Farmer Green picked 20 carrots. He cooked 2/3 of them. 2/3 of 20, right? And then gave 5 to his rabbits. Write the expression that tells how many carrots he had left. So, based on this, which one of these expressions should go on the line? How would you actually solve that? Then Farmer Green picked 20 carrots. He cooked 5 of them. Picked 20 carrots. He cooked 5 of them. So what did he do? Did he add? Did he take away? And then gave 2/3 of the remaining carrots to his rabbits. Write the expression that tells how many carrots the rabbits will get. All right, that's going to do it for a problem set. This is what you're taking on right now. After the concept development, based on what we just did, you're going back and you're completing the problem set. You can come back after you have finished and check the problem set debrief part 3.